Alrighty guys, here is a short video on solving systems by substitution. I've already done one on graphing. So systems being two equations that we have to find a solution, which is an ordered pair, x comma y, that makes both equations true. So substitution is an algebraic method to solving these systems. And so I have my step-by-step here that we're going to follow. And it may kind of seem like gibberish right now, but it'll make a little bit more sense when we see the actual equations. But we look and see which equation is solved for a variable. It could be solved for y or x, and in ours they're going to be solved for y. Take that equation, take that expression, whatever y is equal to, and substitute it in to the other equation. This should create an equation that has all the same variables. So once you have an equation with all the same variables, solve the new equation for its variable. This is going to give you either x or y. Now, I need to go find the other one. So I'm going to take that x value, that y value, plug it into the equation that is solved for y or solved for x, just that solve for a variable, and plug it into that equation so you can solve for that other variable. Now you should have your x value and your y value, and you can write your solution as an ordered pair. Okay. Alright, so let's look at number 4. So if I'm looking at number 4, we have now both of these are solved for y here. Okay, so it really doesn't matter which one you choose. Today we started with the second one. So if y is equal to 2x, I take this 2x and I put it into the y spot here. Because both of these are equal to y, so if they're both equal to y, then we should be able to set them equal to each other. So we put 2x into y spot and get 2x equals x plus 15. And this is going to create variables on both sides. So your next step is take this variable, get it to the left. And so if this is a positive x, we're going to take this x away. If we have 2x and we take away 1x, we're left with 1x, or just plain old x, equals, these went away, 15. So we're done there. Now sometimes you may end up with a coefficient right here when you subtract, which would mean you need to divide out by that coefficient. But for this one, we are done with the x piece. Alright, so we know that x is 15, so you can take 15, put it back into either expression to solve for your y for this particular problem. My students like this multiplication expression today though. So we're going to take the 15 and we're going to plug it back into y equals 2x. So we'll have y equals 2 times 15, which gives us 30. So our solution will be 15, 30. Alright, now notice in number 8, it looks different than number 4, okay? Because in number 4, they were both solved for y. Here we have a standard form equation, and here we have a slope-intercept form equation. So, which is actually the perfect setup for slope-intercept. It matches my rules even better. So you find the one that's solved for a variable, which is my second one, because it's solved for y. You take what it's equal to, and you put it in that y spot, okay? So I keep my 10x plus 3, put in this expression, 2x plus 5 equals 19. So I'm plugging this expression into this top equation. Now I have all x's, oh that's a 10x. Now I have all x's so I can solve, okay? So I keep my 10x, I distribute my 3 into both terms and get 6x plus 15 equals 19. Combine my x terms, 10 and 6 make 16x plus 15 equals 19. Minus my 15, so 16x equals 4. Divide by my 16, just solving an equation here, and 4 divided by 16 is 1/4. So step 3 says plug your solution back into the equation that is solved for a variable. So I'm going to plug my solution back into my x variable in the second equation and get y equals 2 times 1/4, 2 times 1/4 plus 5. 2 times 1/4 is 1/2, and 1/2 plus 5 is 5.5. So when we put this into our parentheses, I'm going to scoot up to my answer blank. I'm going to write 1/4, comma, 5.5 will be my answer. Okay. So it's okay to get decimals, it's okay to get fractions. Alright, let's look at when you actually have to write an equation, or you have to write your system. You have to come up with your equations and then tell what your solutions mean. So I told my students today, in these type equations, you will have 2 different things you're talking about, people, items, whatever it may be. So in this one, together, Preston and Horatio, so those are the 2 variables in this, have 49 total games. So I told them your first equation will always be your total amount of your items. Your second equation or sentence will compare the 2. So that's exactly what happens here. It says Preston and Horatio have 49 games. Horatio has 11 more games than Preston. So the first thing that we do is define variables, and the person or the thing that you have more of gets the y variable. So Horatio has 11 more than Preston, so Horatio has the most, so he's going to be our y variable. So y equals Horatio, and x equals Preston. Now, the way we write this first sentence, that they total together have 49 games, well, x, which is how many Preston has, plus y, how many Horatio has, equals 49. Now, Horatio has, he has more, so Horatio has, y equals 11 more games than Preston. So more than is tricky, so you do I'm going to do a P, but not P. X is for Preston. So x plus 11. And then from there, you solve it like a normal system. So we take the fact that y equals x plus 11, and we put it in y spot right there. Okay, and so we get x plus 11 equals 49. Combine like terms gives me 2x plus 11 equals 49. Take away my 11 and get 2x equals 38. Divide by 2 and get x equals 19, sorry. So x equals 19. So to get, we got our x, but we need our y. So we take that 19 and plug it back into the equation that says y equals. So y equals 19 plus 11, which equals 30. So now let's tell what those numbers mean. So the 19 is for Preston, so Preston has 19 games, and Horatio, which is y, has 30 games. Make sure you have all of that for your answer. Okay, so the main thing with this is just take your time and make sure you're not making any careless errors and substituting everything in right. So this is a perfect lesson for propping your feet up and getting you a snack, and then just enjoying what you're doing as much as you can and take your time and not try to rush through it. Have a fantastic afternoon.